Now let us continue the next segment, that is the last portion of understanding what we're doing with the chill water piping is for the section drawing. Okay, and what we have to learn inside the section drawing usually is people usually want the engineers to prepare, or the engineer wants the draftsman to prepare some kind of a section view for you. If this is the whole plan of yours, this is the actual plan. Maybe you are cutting down a section this way like this to view only this much zone. Okay, maybe you're cutting down a section this way to view only this much zone of the complete plan. So how do you actually do that is what we're going to study today. For understanding this, you should know 2 or 3 different things. One is called your FFL, the other is FCL, and the last is SSL. This is finished floor level, FCL is fall ceiling level, SSL is your structure slab level. Okay, so you should know the full forms, you should know how it is going to be. And now what you have to actually understand from this particular elevation drawing, this is also a project initialized with SM Techno here. So this is the drafting done by one of our draftsmen in the institute, and this is a creative project already into existence presently. And from this complete plan, what you have to understand is it is a multi-story building, directly starting from your ground floor until 20 to 21 flooring area. You can see there's 21 floors, and then lastly there's a terrace area, roof area. So here this building is what we are going to see from the front view, not the top view. We're looking at it from the front view, and you can see each and every distance, the second floor, the third floor, the fourth floor, all of them is maintained at one particular height called 3650 mm. Now calculate that and tell me how much is that in feet. It has to be nearly 10 feet, 9 feet, 11 feet. How would you do that? You should know that better. You have to tell me how much is that in terms of feet and inches. Nearly 12 feet, right? So 12 feet, that is the total from your FFL to the SSL. In between is where your FCL level rises. FFL is nothing but the place, the ground floor level where you keep your legs, and the top level, that is the next floor for the next FFL of the next floor, is marked with the SSL of the existing floor. Pele you will get the slab level, and over the slab level is what the finished level for the next floor will generate. So each and every height is maintained as 12 feet. That is okay. Now if I'm going to come to the interior of this, is what you will be seeing that every segment is marked very, very clearly between all type of levels. You can see here, this is the double line existence is your FFL, finished floor level, up to the fall ceiling level. This is your fall ceiling level. It is how much? It says that is 2720 from FFL to FCL. Next you have from FFL to the SSL without the slab thickness is 3270. Next, your total thickness of your fall ceiling is 550 mm. That is nearly to 600 mm, like 2 feet. Okay, yes, the fall ceiling, the space over the fall ceiling for the services to run. Now the thickness of the fall ceiling is 25 mm, 1 inch. Then you have something called 280, which is nearly to 300 mm. That is, this particular segment is your slab thickness of 1 feet before the next floor is started. And between that also you have another thing called 100 mm, which is called the air void space, thermal membrane, air thermal membrane. You are going to leave that much of gap in terms of an insulation. You can do that with any kind of insulation depending upon the structural engineer is going to decide. But you have to leave at least 4 inches before the next tiles of the next floor is going to be applied. Fine. So this is how different levels are accommodated and elaborated here. This is for your example that how the levels have to be applied. So we are going to take the example of this one, and I'm now going to open before you the complete, this is where we did the chill water piping, right? This is the complete area with your complete HVAC drawing. You can see there are FCUs and AHUs connected with the ducts. The insulation is provided. You have your, if I can just turn and try to show you my pipes. If I'm going to go here to my layers, in this one we have your chill water pipes here. That is, they are taken from the last portion, not from the center. Fine. So this is your chill water pipes that you can see, chill water return, chill water supply, and etc. All the annotations, the dimensions, everything is given to you. And inside this particular plan or this complete view is what we are going to create a section drawing only and only where I feel that there is a complication in understanding. So usually you should see that the section drawings are drawn only and only created by the draftsman on the authority of the engineer for proper understanding of only that particular segment, which is called a section drawing. So from the complete plan, maybe I'm going to try to focus on this much area. You can see that with the marking A until to this place where there is a kitchen hood. Why I'm selecting only this portion is because I have every supported quantity of the HVAC listed. We have the chill waters, we have the ducts, we have the flexible connection, then we have so many things that are all over it, so that everything becomes very handy for me to understand how to deal with the section drawing. Fine. So what we are going to actually do from here is we have created this section drawing, but to remember, whenever you're going to do the section drawing, you do not have to work in one single viewport. We are going to change or duplicate the complete screen into two halves, where same plan is going to be looking below and above both. For that, we have a command called viewport center, and you will be getting a viewport screen. From there, currently you are using a single viewport, that is this one. Now, because I have my original plan above and I want to draw something below, I cannot actually have my vertical type of viewport. I need to have it equal above and below. So maybe I'll take 2 for horizontal. Now maybe if you're going to work in a completely M.E.P drawing by trying to look for same drawing but different segments, you can suppose this is going to be M.E.P, from this is HVAC, electrical, plumbing and firefighting, all 4 different designs of the same model. So what you can do is you can try to change that to 4 different viewports. Alright, so we are going to do that for 2 in horizontal way. One, I'm going to keep the original section above and create my section drawing below. I'm going to click OK, and you can see my screen divides into 2 equal halves. Now if I'm going to move here and try to zoom, only this portion zooms. This portion is not touched. If I'm coming here and if I'm going to zoom again, you see that is only being zoomed. Why? Because see, look at my cursor in this portion and look at the cursor in that portion. This is software activated. This is system activated. If I'm going to click inside this viewport and try to zoom in and zoom out, it will zoom then. If I'm going to come back, see, only one can zoom at a time. So if I'm going to come here, try to zoom, it is not enabled. I have to click here, try to zoom, try to keep that particular section on the screen which I'm looking forward for. This way, the maximum zoom from A till the kitchen hood. And over here is what I want to do is try to create an empty room for me to draw one particular architectural slab this way of only and only this much section. So what we are going to do is I'm going to come to an empty space inside and I'm going to zoom that very nicely. Here I'm going to draw one single line. Remember, we have architectural drawing layout for which we can actually try to go that way. It is currently locked. I can just turn that on and make that as the current layer, and you can see that is available. If I'm going to use line and just draw one particular line of any particular length, but my offset has total to be dependent upon the actual floor height, that is nearly 12 feet. Alright, it can even increase. So we can even take a little more. I am going to make some modification to this because we are focusing on looking at our internal services. So I'm going to increase the false ceiling height from 2 feet to 4 feet. Right? So now what I'm going to do is coming back here, total offset, it is currently 3650. I'm going to take that off 3800. Fine. Coming back here, take the offset for 3800 directly from here and above. Zoom out a little bit, then you will get the portion this way. Fine. So that becomes extremely huge. Suppose if I have taken the offset of 3700, just 50 mm more than that one, you can see it comes very close to that one. So let us continue with 3700 and rather not this portion. So where do I actually click and where do I actually not click? All is that dependent over your original plan view at this end. This is only the initial drawing. If I'm going to click here and try to look up the starting wall position, because we're going to create the architectural part, so we need to start with the walls. But if I'm going to start with the walls, remember the portion A from where it is starting, only the section will be seen from there. So why to create from the wall? I can start directly creating from this end. Fine. So what I'm going to do is we are going to use the construction line the architectural view. This portion here, this portion here, and we are done with the available space. Trim the extra lines that are not required. From this side, these ones, these from the above. I'll have to do that very keenly because it can delete the rest of the portion as well. That is done. This is done. So this is the place where things are going to be applied. Now from the main drawing again, I have to see for where are the walls, where are the columns and etc. for me to create the partitions for running the duct, the diffusers and etc. Fine. So from the starting, from this portion A, I am having the first wall here in this portion. So Excel enter, V enter once more, keeping your architectural layout active. I'm going to create on the first wall portion and you can see that is created below. From there, what is the next architectural part or the structural part is the structure, is the column. This is one, this is second. So now from these two boundary areas, this becomes a concrete structure, this becomes the brick wall. Fine. So coming back to my viewport again, TR double enter trim, that is not required. Fine. We are now try to look up this one only. I'll try to move the whole interface a little below so that becomes a little easy for working out. Yeah, that way. Now in this particular drawing, what you have to do is you have to create all the levels as per this particular drawing. So this drawing was taken and only for reference key what comes after each and every position. Fine. So what we are going to do is we can either start from below or we can start from above. You can start doing the offset from below or you can start doing from the above. If you are going to do from above, you have to start from 100 mm. That is the thickness for your air void thickness for the structure. That can become a little confusing, so I'm going to start from below. Fine. Remember, we have the total height of 3700. I'm going to create the same condition space of 2720 until my false ceiling. This is the condition space, that is where the people will be walking and doing the work and etc. That is from FFL to my FCL. That is 2720. To come back here, select this line or take offset for 2720 and enter. You see, this much is my condition space. Fine. Now inside the condition space and over here, you have to keep checking how much is the distance left. How much is that? That is 980 mm, nearly to 1000. I want to keep my false ceiling alone for nearly 4 feet. How much would be 4 feet in terms of mm? 2 feet is 600 mm. 600 plus 600 becomes 1200 mm. 1200 mm becomes exactly 4 feet. Fine. So what we are going to do is instead of 4 feet, if suppose I'm going to maintain 3 feet, how much would that be then? 900 mm. Fine. So the 900 mm would now become easily available for me here. From this point till the next point, suppose if I'm going to take an offset of 900 like this, only how much is left? 80 mm will be left, but that will not give me the rest of the portion. Fine. So what I'm going to do is from the total slab thickness or from 3700, I'm going to make that again for totally 38. If I'm going to do 38, 80 plus 1 would become 180, the extra space that I'm going to get. So what we can do is for enough space and large area, I'll take an offset of directly 4000 from this portion to above, and I'm going to delete the topmost. I'll not delete that initially. I'll just mark the lines first. so that we can get enough room for showing you the practice how it is going to be done. Same is for these two. And I'm going to support them onto this side of the plan, and then we are going to do the work for the stretching. Select both the lines, carry them. This one again, try to do that in this position. And now I have the efficiency to delete this portion so that it doesn't become a part of disturbance for me. So that is done, and we are having this as the false ceiling level of 300 feet, and now I'm having little space, so over there I can apply the 300 mm of structure slab and also the 100 mm of my void space. So from here, how much I need again, what you call, from the FFL, you can come to the drawing and see what we have next. After 550 is what I have my 280, right? So 280 plus 100 is totally 380. So we can take directly 400 instead of keeping 380, the odd number. So from here, take an offset of 400 again. So you will be creating one exactly on this portion. And I need to differentiate that, so I'll take an offset of 280 first above. So the rest of the line is my air membrane. Fine, that is understood. Now inside the false ceiling area, you have to understand which all things are going to extend and which are not. My structure is all over the building, so that is going to be applicable all over the design, but the wall is not going to be entered inside the false ceiling or the slab and etc. So you have to come TR double enter, trim it from the false ceiling area, and it is only and only available inside your condition space. Fine. So now, because this is a wall, this is a column, and we don't want to just name them, we can do the purpose of hatching. And remember, the void space that we have also created, the slab, that is also going to become of concrete. So I'm going to select these two portions, do the hatch for them. I'm going to select the swatch portion as brick because that is what is the wall. Select, I'll try to give that a little color, maybe for identification. I can give red. This portion, enter, pick the point, this is the point, change the scale to 50, preview, and you cannot see that still, 200, now you can see that one, right? It's clear. So I'm not going to do that again for red, maybe I'll go with same dark color by layer, and okay. And you can see we have the wall portion here. This is not going to be the wall, this is going to be the concrete, and the concrete is all not going to mix up this way very nicely. So we have to create portions where it is available to us. So you have TR double enter, it's going to be continuous, this side, this side, this side, and this side, all the four corners. This is the complete structure slab level for you. So we have the hatching for that also. We are going to use concrete, that is this concrete. Click OK, select the object, come up here, this is the line, this one, this one, these two, and this one, and enter. Pick up lines, come in interior, and you can see the hatching is too huge for that to apply. The close boundary could not be determined. Okay, we did not select this portion as well. Fine, we'll come back to that. So I'm going to press at enter, and the least that I can create is 2. I'll try to see the preview and click OK and cancel out of that. That did not actually work with the hatching. Where is my concrete? Okay, pick up this, and enter. pick up line, this portion and this portion. Enter. Go and put that up very small, and you can see that's too small to view. Let's go with 25. Preview. You can see something, right? It's very nicely done. I'll just increase that to 50 for the eye level to be very easy to view. That's fine and okay. And that is the column and the slab level that we have. Now from this complete drawing, what we need to do is we are looking at everything from the side. Alright, from the side view. So you are standing on the black line and you're looking at each and everything. So the complete HVAC drafting is going to look and performed as if it is from the side. So now if you're going to look at the HU from the side, how is that going to look? Tell me. Now also inside the service area, what all things are going to apply from above to below? What is the first service, what is the second service, and etc. The first service would be firefighting, then you have plumbing, then you have the electrical lighting fixtures, and lastly you have the HU, the HVAC that is near to the false ceiling, right? So what I'm going to do is with plumbing, firefighting and electrical, I'm distributing totally 2 feet for them. Alright, 2 feet, or maybe I'll keep 1.5 feet for them. The rest 1.5 feet is left for HVAC drawing. So from here 1.5 feet means how much mm? Mm. 300 mm is 1 feet. So for 1.5 how much? 450. Okay, so 450 is going to be correct. Let me check how much is the room I have here totally. That is 900 exactly. It will become half of it. That is totally 300. So I'm going to give 1 feet for that as of now. So I'm going to take an offset of 300 mm from above, and I'm going to use my text to apply there. Call that firefighting and plumbing and Is it fine? All 3 of them are going to come above the HVAC line. So all I have is this much of room for doing the HVAC drafting. Fine. So coming back to the section drawing, what we are going to start very quickly is the AHU that you have, what you're going to create, and you have the information. All you can see is the size and everything. So if you're going to read from there, it is giving you 550 by 300. Width is 550, height is 300 for the duct that is moving, right? And here what you have also is the CFM, 1602 CFM. That is nearly how much of TR? 4 TR. 4 TR of machine, that is the AHU. Fine. So what you have to do now is you have to create an AHU that is using Excel lines, but just remember always whatever commodity you're drawing, select that first, see what layer it is, because when you're going to come here you have to draw in the same layer. So select machine, this is machine, use XL, enter, V, enter. Inside this plan, move here and then click here once again, and you will be getting the place for the AHU. Fine. So now how do we actually apply and understand how much is the actual dimensions of the AHU going to be, or what would be the bottom of duct, or etc. Right. So from here what you're going to do, you know that what is the height of your duct? 300 is the height. So at what height would be your AHU from below? From the false ceiling it will be at 300 mm, right? So now what you have to do is try DI, enter this side to this side and check how much is the distance. It is 600. So what you will be doing is you will be drawing one line here, small line, because you can take the offset for that. Excel enter, H enter, if you will do, it will come in this position. But what will happen is, I will show you. XL enter, H enter. Suppose I'm going to do it this level. So नीचे कहाँ बनी line देखो आप, वहाँ पर आई जहाँ पर बनना चाहिए. This particular line where I'm going to select that portion, where is that? It is on this position, right? So you cannot actually try to do that. We are taking reference of only the elevation, not only of the vertical. Always we are not going to select that one. That is why I'm taking an offset from below for you to make you understand how it will be, right? So as per the height, we have an offset of 300 mm there. From here, take an offset. This is your AHU actually placed. Delete this one. You steer double enter. You don't have AHU lines here. You don't have here. You don't have them here. And you can select all and delete them. This is where your AHU is placed. Take a line and join them. This is how it will be looking in the section drawing. And remember, section drawing is totally a rough sketch. It need not be totally of your exact calculation, exact method, exact size or anything. It is only one view that you are creating for reference. Right, I can create the whole thing in one color also. I am doing it purposely in different as per the matching layers because you can identify what we have drawn below. Fine. So next after that, what we have inside the section is the canvas cloth, right? So in my connection, in my section drawing, I will already understand that the HU and there is a canvas cloth like the SLD drawing. So directly I'll be looking forward to where is my mouthpiece and how the duct is starting. Now you see what is the size of the duct is 550. So what is a half of 550? 225? 275. Alright, 275 is the actual position. Now suppose if I'm going to draw that exactly here, first of all, if you're looking for the duct from the side view, how is the duct going to respond? Can you see the other end of the duct? No, we can see only one side of the duct. Remember, this is a section drawing, not from the top. So you're drawing exactly what you're going to see. Fine. So from here, suppose if I'm going to draw one line, let me check what layer is that. For the, it is SAD. So I'll try to keep SAD on. SAD, come back here. Draw one line from the center up to any limit, up to any extent. And I'll try to take an offset of 275 above and below. You see what happens? One line there, one line here. So that exactly goes off from the connection from my AHU, right? So I cannot actually take the offset depending upon this side. What I'm going to now do is remove all these. And exactly I'm going to take the reference for my XL enter, V enter, draw where is the portion of connection. And this side you can see is the type that is connecting to my AHU. Now that is, we all know it is at 40. So taking the reference of the mouthpiece from here is, we already know that it is going to be at 45-degree angle, the creation of the mouthpiece. Coming back here, what we're going to do is we are going to try to keep that or make that exactly. Suppose if I'm going to have one line here above, one portion of the line there, offset of 275 below is what it will come here. So anyway, I cannot see the other end. So maybe I'll try to look at this end, this portion. So if this is going to be the exact place where my duct is going to run, suppose I'm going to pull that out there, remove this line, and from here is what I can try to manage to link it with the polar tracking type, like here, like this. It will not be 45 degrees. It is not going to be 45. This is 45 above. You are only showing that the mouthpiece and then there is connection of the duct. Section drawing is only and only limited for that purpose, right? So select this line here, not requiring that, but I do require it here. I'll trim from there, trim from here. Select the other portions and try to delete them, not for my reference, right? So this marks the mouthpiece, and from here is your complete ducting. Now inside the duct, what you can also see is this line and this line. Until where is that coming from? Okay, I can delete that. Next, inside the view, you can see I am having a diffuser that is applied. So inside my section, if I'm going to stand here, can I see the other connections behind the diffuser? None can be seen. I cannot see the flexible duct, I cannot see the butterfly damper, I can only see as if the diffuser is directly connected to some part of the body to this duct. Is it clear? So we now have to do the creation of this particular diffuser inside this portion, inside this drawing. But how would we know what is the layer? Select on this, it is SCD. Come back to my layer here. Select SED. Go back here, use XL enter, V enter. And from this side to this side is what we have to mark. Now you can see that particular portion is coming here, but we actually forgot to give the thickness to the false ceiling, the 25 mm. So I'm going to do that. First, a set of 25 mm for the false ceiling below, and that is the thickness provided here. Next, what we have to see is the diffuser that we are going to draw has to come inside the thickness of the wall. Inside the thickness of my false ceiling, not anywhere above the false ceiling. So here in this particular place that you have actually got the marking, how you have to show the diffuser is, you are going to use the polyline with ortho turned on. You are going to start sketching from this side, totally this side, and I'm not going to do that below. First I'll show you how to do the thing. Turn off the ortho, come back here, keep polar tracking on, keep 45 on, the incrementing angle. Take a line, and we know that if we are going to see for a diffuser from the section view, you can see the blades only. The blades forming the passage for the air to move. That is what we are going to create here. We are going to take the angle for 45 degree. Where is my 45 degree coming? I have to hunt for 45. Why is it coming below? Alright, there. So now I cannot take the offset multiple times because offset is going to lie exactly in the line. It will come down. I have to copy that a number of times. So before copying, try to erase what is not required because that would be applying everywhere. How do we actually copy? You have to copy with some displacement values. That is a blade at every 1 inch. So CO enter, select this, keep ortho turned on. From this midpoint, offset for 25, copy for 25 mm. The next offset should be plus 25, the last entered. That is going to be 50. And then one more, 75. And then one more, 100. And then you can see, if you feel that you have exactly reached in the center point, you can stop. If not, you can give one more. 100 plus 25 becomes 125. And then you can press escape. Now you have to do the same on the other side. The best possible way for me to do is mirror. MI enter, select all the 4 quantities, just move above and you can see all 5 of them are leading the side on the right end. Click, erase, no, and this is how you do. Use your polyline once again. From the last entered blade, cover this portion. Same thing from here to here, and in the center line, whatever line you have, just trim that. Now you're free to trim this one, this side and this side, and you will be getting, but also for reference purpose what I can do is I'll try to keep one line above so that you can understand that there is a connection and it is not a ductless type. I'm going to trim only the one that is inside the false ceiling place this way. The other two from above I'm going to delete so that you can see that it is connected via duct. The duct is not going to go inside the main duct. It is only a connection like this. Fine. So now that can be a connection with GI sheet or with flexible duct. For understanding that, you have to open the complete plan view. Otherwise it is only done this much. Next, what we have from here is, if we are going to continue to see, we have a reducer, and the reducer is followed by the elbow. Now you see, if you're going to see from the side, how can you see the elbow? You cannot see something turning. But we have to create a portion in the section drawing which is going to make us understand that there is a turning taking place. And after the turn, whatever is there on this side, you see that the duct is reducing from 450 to 300. 100 mm is reduced. But can we see that? No, we cannot see that how much it is reducing. Why? Because we are at this particular section. If we were at this particular section viewing it diagonally or the right hand side, we could have seen the duct reducing, but we are at this particular stage, so we cannot see that reducing. What we need to do, the next reference, is come to this plan, select the SAD back, take the XL enter, V enter for the reference of the starting of your reducer, decide where it is ending and the beginning of your elbow, this portion of the elbow where it is taking a turn and where it is totally ending. Now directly after the elbow is ended, what you can see the butterfly damper, right? Because you are from the section view. Now until this position is what you have to show that there is a turning, but from where? See, from here, no. From here, no. You have to show the turning from this end to this end, right? So from this portion to this portion is what I'm going to make a different color selection so that you can understand that we have to mark from this side. We are going to trim the extra lines that is not delete. I'm coming here and to show you how to make the turning of the elbow. We first have to select this line. We have to use copy command. Now you can zoom to the most depth and you can see that the turning is taking from this end to this end, so it has to go from far to very close. So from this segment, what you have to do is you have to start copying very closely. Zoom the total that you can. You see, if I'm going to paste at that closest, it's not taking the copy. The earliest it can take is at 18 inches or 18 mm. Place one there and the other one there and the other one there and the other one there, and keep increasing very slightly, knowing that the distance is increasing after the turn. From this end, maybe I'll take a drastic turn of this much and maybe this much and maybe this much, and I'm going to increase that further. This way, this way, this way, increase a little bit from the lastly entered, this side, this side, this side, up to here, this way, and we're done. So now in this particular position, what happened to this? You can see that there is a turn or something that is taking place as if from this portion, and it is just going and mixing that way. So it looks like a turn is taking. Alright, so we have to keep these lines as it is, because that is what is going to make us understand that it is the elbow and it is taking a turn within the duct. Fine. So after this one, what you have next inside here is your butterfly damper and directly the flexible duct. Now when you're going to connect the flexible duct, in the section view it will look as if the flexible duct is connected to your return diffuser, but actual practice that doesn't happen. Why would we connect a flexible duct to a return diffuser? We will be connecting that to the supply diffuser, but because the supply diffuser is exactly some distance behind the return diffuser, we cannot see that inside the section view, right? So if it is going to be like this, you have to create a drawing where the flexible connection is connecting to my return diffuser. Before that, we will be giving a marking, XL enter, V enter from the beginning of my butterfly damper, because that can be seen from below, from this end to it is starting from this end here. So here will be the butterfly damper, and from this portion is where we are going to mark the duct, sorry, the diffuser. So this line and this line I'll just draw and later match that one. I'm going to come here, and I'll just trim what is not required for me. Select and delete. TR double enter, trim this. Select the whole thing, delete that, trim, And here is how would you think the butterfly damper would look in the section drawing. Can you see how it looks inside the duct? It will not look like directly above like this complete donut. It will look like half of the donut. Only half of the blade is corresponding to you. So what you are going to do there is you're going to create a circle like this, but you're not going to cut the circle from between. You're going to cut it. After you cut also, you have to cut again. Suppose you're going to do this way and you're going to trim off this part. Is what is the section drawing going to look like. Fine. Now from here until here and in this position is we have to draw the return diffuser. Come back to the view, select the return diffuser, it is RCD, press escape, come inside this view, select RCD wherever it is, RCD, use your polyline, and that is also going to be inside your false ceiling, right? Start jumping, keep your ortho turned on, see my ortho is not on right at the moment, fix it here and press escape, zoom in, keep your polar tracking on, use line, one line in the 45-degree angle, this way. TR double enter, trim the above portion, TR double enter. Next you have to do the same way, you have to copy that, keep your polar, your ortho on again, selecting this object at every 25 mm, 25, 50, 75, 100, 125, and that is done. MI enter, select all the 4 lines, from here move above, click, and then it is done. Use polyline once again, match them to show the opening, TR double enter, just trim this portion, it is done. Trim the duct below as well. And now here is what I'm not going to show the duct, I'm going to show the flexible duct. So I don't really require this portion also, but I will be deleting this after I try to capture my flexible duct. So for drawing the flexible duct, I need to draw my SP line, and then I need to use the measure command. So if I'm going to select this, it says FLX is the layer. I'm going to drop FLX, come into this, take my SP line, start from the midpoint, take a turn, go here, try to join with the midpoint, press enter. Try to make that little comfortable to view. Yes, that looks quite near to that. Now I need to measure that, but for doing the measurement I need to know what is the block selected. How do I get to know what the block is? I'll have to double click on any individual item, and you see the name is given as 1. You have another one also called 1, 2. You have another one called 1, 3, 1, 2, 3. That is the name of the block when you're going to insert inside ME enter or the measure command. So I can use any of the 3, 1, 1, 2 or 1, 2, 3. I'm going to cancel that. Come back here. Use ME enter command. Select the object. Use B enter. Insert the name as 1, 2, 3 and enter. Align with object, yes. Segment, I don't really know how much is a segment. I'm going to give 25 as such, and you see it is created with 25 only, and you can see the flexible duct is applied. Now since the flexible duct is applied, I can select these 2 lines and I can just delete them. I don't require the reference anymore. So this is how your section view is completed. Now anything that you can see after this one? No, but you can see the chill water pipes, right? So the chill water pipes will have to mark the reference directly as it is, because from the section view what you're seeing, the view is not completing there, but it is falling inside. So select this pipe, it is WCHR, come here, where is that C alphabet, take this one, go back here, Excel enter, V enter, Wherever is that particular pipe, just draw over it for understanding, and I can do the same thing again for supply as well, and I can then later on mark with the layer. Oh, I just deleted that back. XL enter, V enter, draw that and select it here, and it is also updated this side. Fine, there is not a problem. TR double enter, trim there, trim from here, trim from inside the false ceiling, select the two and delete. That is done. So that is not going to come inside the false ceiling, so trim them from here again. That is also completed. Those are your chill water pipes. Fine. That is how it is going to look for you. Now what we have next is, if you're going to come on the other side after the HU, we can find inside the above the section is you have a red color duct. What is this red color duct? Which type of duct? No. See, for the return diffuser, the return duct is not there, right? It is empty. This is your exhaust duct, right? Exhaust duct, and that is given that it has a size 150 by 150. So if I'm going to see from here, it is going to look exactly as if it is touched the bottom of the HU from the side. So what I'm going to do, come back here from this line, take an offset of 150 below. Exactly, this is a position where my exhaust duct is going to be applied. So if I'm going to select this duct, it says exhaust duct. Come back here, select this one, match with the same exhaust duct layer, and is what the exhaust duct is going to look like. But you see, the exhaust duct is completing until we are looking forward, right? So it has to be of some particular distance. And how we measure the distance? XL enter, V enter. We are going to mark the starting where it is, this side, and we are going to go until this end, and you can see there is a elbow again. So we have to show the elbow, and up to this end is where it is coming, right? Select all these lines. Select this line, extend to this part, extend to this part, and we know the size is 150, so overall size we have to take offset of 150. Click above, and you can see it is joined that way. This is a starting portion, so trim the extra lines that is not required here also. TR double enter, this side, it is not moving anywhere, this end. We can clean that up a little later. So this is the exhaust duct that we have. It is also done. Now you see, if I'm going to click this side and I'm going to click this side, is where before we end from last portion is you have the turning point, and after that we cannot see where it is turning to because we are not in that section. So we have to draw the same turning point once again. So I'm going to copy, and remember it is turning on the other side, so this side has to be the small one. So zoom in, select, copy, select the part, use the center point, come, try to click once, then again, from there, the completion of my exhaust duct is also done. Lastly, what is left inside this room, that is inside this area, we have a kitchen hood. Now for creating the kitchen hood is what you need to have a platform where you're going to stand up to some height to make the cooking. Fine. So as per the thumb rule and as per the designing estimation standards, we have that limited to at least 700 mm. Right, you will be getting in your kitchen ventilation systems how to do the kitchen hood design and etc. So we first need to create a platform of up to 700 mm. 700 mm is how much feet? Just little more than 2 feet. 2 feet 4 inches, you can say. So I'm going to create that using L enter. I'm having a red colored object selected. I'll take the exhaust duct. Offset force directly 700 mm and above. This 2 feet की सीढ़ी नहीं, जो cooking store है आपका, nearly it can be 800 mm also, 200 to 800 mm of height. So where you're going to stand and do the cooking, that has to be at least minimum 2 feet, nearly. So 2 feet is 600 mm. I'm taking little more than that. I can take 800 also, not a problem. From here is what we are going. If we are going to trace this, this is only the platform. अभी इसके ऊपर चुल्ला भी रखना है. आई बात समझ में? So we have to keep the stove above this one. I'm going to take an offset of maybe nearly. If I take 4 inches, it's going to be look very small. So I'll take off 200 mm. And I'm going to create or make that look like it is some distance from here. How much is that? 207. Little nice and decent, right? I don't really require this portion now. This one. So from here is where you're now going to do the kitchen hood inside your section drawing. So inside the section drawing, usually you know how the kitchen hood looks. It's like a chimney. It has only this forehead above. If you want, I can show you one image. I think you people know how it looks. Kitchen hood cabinets inside hotels and etc. Mr. Mario, I think you already have that in your house in US, right? So it usually has these kind, and what we are looking forward to is create something of this way, exactly the same shape, like this or like this or like this, from the section view, right? So this is what I want to create there. For doing that, I have to first come here, select the point or the object. It says the layer is called hood. So I'm going to bring the hood into existence. Take the reference, Excel enter, V enter. For the duct where it is to be marked from first, or the starting and the ending portion, and can also be useful. This side to this side is where my kitchen hood lies. And the inside duct portion is actually from this end to this end. Is it fine? And from here, what I'm going to do is, from the line of my stove, I'm going to make a distance of at least offset for 500 mm. This much space. 500 mm becomes a little less. It will be too near offset of 800. Let me check how far that does appear. Okay, this much distance is okay for you to understand. So from here 800 mm ki duri par is what your smoke is going to relay or get sucked by the kitchen hood. 800 mm. Nearly I'm trying to keep. You can keep 1000 mm also, right? The more offset you keep, the small will be your kitchen hood. So I don't really want it to become very small also. So coming from here, I'm going to extend these lines to both the ends, the side and the side. We can just delete what we don't require. Too much confusion with that. Yeah. Now inside the drawing that you have, if I'm going to zoom in there, nothing else is available for me to do the vertical axis, right? So inside here, what I'm going to do is, from this end of the corner, I'm going to use my polar tracking, alright, marked that at 45-degree angle. Take a line from this end. I'm going to bother to mark 145-degree angle here. From this end, I'm going to mark another 45-degree angle here, right? Trim the lines interior, and from here is what I need to remove mine, and I need to join them first to give a realistic look. TR double enter, trim this portion, and now I can delete these lines after the reference is done. I can trim this part, TR double enter, this part, oops, match it with the same layer. There is your kitchen hood applied. Kitchen hood is not going to go inside your false ceiling or anywhere. From here you can start just deleting that. That is also completed. Lastly, what you are having is this is done. It is exactly how it is going to look like. It is going to be below, it's not going to be above, right? And here is where your section is ending. So in this position where the section is ending, what you have to do is you have to create a break line. We have seen what is a break line look like. Use the break line command. Start from this side. What happened to that? Break line, enter. I'm going to start from this end. Why is it behaving that way? My command is not active. Break line, enter. There is no function. Select the problem. Now I have something wrong there. Maybe their file is corrupted. That is not a problem. Fine. So now we have completed each and everything very clearly, very neatly. We can just clean up what we don't require, and this is your complete section drawing. You can see this is how it is done. Very simple. You just have to take and drop each and everything below, right? I have some things to clean up here as well. Just hold them with the shift key and delete. And the side. Now what we have to do is we have to give the marking for each and everything, because in the section drawing, marking is very efficient and very important. So using your dimension command, you have to mark each and everything like DLI, enter. From the below to the first segment that you want to mark, maybe you're going to call that BOP or bottom of pipe. So from here, otherwise DLI, enter. From the bottom of the pipe, I'm going to take and mark it until below this side and place that in center. That becomes 2720, right? So it's not that you cannot edit this. You can go to that portion. My god, there's too much mosquitoes here. You can go to that and you can see you have the ability to edit that particular thing. It is 2720. I'm going to make that BOP 2720 because there can be more things of 2720. BOP is bottom of pipe. Okay, so that is okay with me. I'm going to click OK, and that applies here this way. Next I have bottom of duct or bottom of diffuser, BOD. So I'm going to use DLI from this, catching this one, coming down, and you see it is going to mark the same one. So keep your ortho turned on until this position and going to mark it this side. It says 2695. So you have to remember the codes. Highlight bottom of diffuser 2695. We all know that it is going to be in terms of mm and etc. Bottom of diffuser is also done. Then we have bottom of duct. So DLI, select a part of the duct, stretch down, mark somewhere in the between, and check how it is 3044. So double click over that. BOD 3044, bottom of duct. That is also done. What we have next is bottom of exhaust duct. So DLI, this portion, 2 down, mark it 2870, bottom of exhaust air duct. How much was that? 2720, something like that. Okay, and what do we have after that? Bottom of machine, that is my AHU. From there to here, 3020. Remember to select that. Bottom of machine 3020, and okay, that is also done. And what else is left? My from the bottom DLI, from here till the kitchen hood opening. How much is that? 1700. Select it. Bottom of kitchen hood 1700. You see that now all the things that we have done is a little not in line, right? So we have to do one thing, is to select one particular portion and try to update all of them in one location. How is that going to be? Suppose with reference to the BOKH, suppose this is going to get enough room for you to mark it properly. Draw one line from this portion totally this side, this way. Now you will be getting the point to mark over there. Select this, zoom in, click and drag it to that position on the line, and you can see you have put it exactly in the center. Comes the turn for this one, select it, you have a stretch grid, drag the stretch grid over the line, this one to here, and it forms exactly in the center point, very close to that. This is obviously there. This has to come a little more, very slightly. That is done there. This one, where is the point? Come back. This is going to be too far, maybe. Once that is done, you can select that line and delete it. Clear? So now we have to give the text for each and everything. What is called what? This is the FFL level. write FFL, select that, make that into bold, or select a new text Times New Roman 200. I don't want the layer, that one, let it be red. Copy the text, come inside, you can write condition space. This is my FCL, lastly is my SSL. SSL is structure slab level. Change one term here. FCL is fall ceiling level. Lastly, we have condition space. Is it fine? So this complete thing is what is your section drawing, and you can even mention that below. CO, copy, mark that one. Section drawing. Presented by HDE 92. Scale is 1:25. Is it fine? So this way is what your section drawing also completed with the last portion of your HVAC drafting. Is it fine? So it is very simple, very easy to do, very in detail. I have shown you. Any confusion or anything you can ask me later, but first you need to practice, so that without practicing you will not understand anything. Fine. So if I'm going to come out of the command, select these lines, just delete them. This is how you can do it, and this is now going to be saved with a name, different name on the desktop. Section drawing 92. Save. If I'm going to do the viewports, single way, and okay, you can see this looks very neatly. I'm going to create a rectangle beside that to show that this is what is we have done. Select it, blue color.